Hello. They did. They fixed their drum roll. This is 8M4, lesson 2. This is linear and nonlinear expressions in X. And there's a couple things that we need to learn today. We're going to, or really some of it's review even. We're going to talk about the difference between expressions and equations. Then we're going to talk about how you identify linear expressions and nonlinear expressions. And then we're going to do the homework help, and we're going to have, I don't know, like 8-10 examples on the homework help. So this should be very useful for you. If you know expressions and equations, you might skip past slide 1. Slide 2 is going to be talking about how you identify linear expressions and nonlinear expressions, and then all the other slides are homework help. So let's get going with this as I switch over to the new screen. Application window, sketchpad, here we go. Okay, 8M4, lesson 2, expressions versus equations. So what is the difference in an expression versus an equation? You've probably heard your teacher say this a million times, and understanding the difference is extremely important. Let's get our pen size up to a good size, 3.6. That's where we like to do it. Okay, so first of all, an expression are a set of symbols that can be evaluated an equation, and we'll talk about equations in a second. So let's look at some examples of symbols that can be evaluated in parentheses if all variable values are known. So it's really just a set of symbols. And then 2, that can be evaluated if all variable values are known. Okay, so let's look at some examples of expressions. So again, we're talking about expressions here. These are expressions, not equations right now. So let's look at some, and let's make them in, let's use a different color. Oh, I heard someone say orange. Okay, so 4, this is an expression so constants are expressions. So 4, pi, 10, 5/2, these are all expressions. Okay, then they can also be a set of symbols that can be evaluated. So like 5x plus, or just 5x, let's just do that. 5x. So this is a set of symbols, and it can be evaluated if we know the values of x. So like if x is 2, then 5x that equals 10. Okay. You can also have more than just a simple combination of terms. You could say 5x plus 4. Or you could say 5x plus 4 plus y. Well, let's make that separate. So here we've got 5x, we've got 5x plus 4. We could say 5x plus 4 plus y. And we could even say 5x plus 4 plus y squared. These are all expressions. So such as symbols that can be evaluated. You could also say like this: a plus 2b plus 3c plus 4d. That's an expression. You could say x squared over 10. These are all expressions. So I think you get the gist of that. What is not an expression? How about this? How about 4 times plus divided by? Is this an expression? It's a set of symbols. Well, it's a set of symbols, but this is not an expression because it can't be evaluated. It doesn't make sense. 4 times plus divide this is not an expression because it doesn't make sense. Okay, so let's go and let's talk about equations. So equations, it's simply the setting of two expressions, or the statement as equal. So I can take an expression and I put an equal sign and I put another expression. So let's look at some expressions. So I can say 5x, that's an expression. That's one expression. And then I could say that equals another expression. What's another expression over here? I could say 5x equals 10, right? Expression equals expression. And that's an equation. I could say x squared over 10, that's an expression, equals, what's another expression? How about let's choose this one? Equals 5x plus 4 plus y. So that's it. Sorry, that's an equation. So these are equations, right? And what's the key to equations? Look at the equations. What do you see here? We see this equa, just kind of like equals. So if you see an equal sign, then you're talking about an equation. Right? Over here, there is no equals. Right? None of these expressions, well, forget about what I wrote here. I kind of maybe confuse things a little bit. But these are all expressions because there's no equal sign. If you have an equal sign, an expression on either side, that's an equation. Okay, I think I've beaten that one to death. Let's just do a quick test here. 7x plus 14 over 10, that's A. B is plus minus 10 pi 16 r times smiley face. And then we have C, we have 42 equals n over 16. One of these is an equation, one's an expression, and one is neither. So for those of you who said this is well, pause and try. This is neither. This is an equation. And how do we know it's, well, and this is a expression, right? No equal sign. This is neither because it's nonsense. And this is an equation because you have two expressions with equal in middle. Okay, moving forward. Now let's talk about linear expressions. So we're not going to tell you why linear expressions are actually linear expressions. A linear expression is an expression, well, let's just say it's an expression that when graphed forms a straight line. Okay, but we're not going to talk about, we're not going to be doing any graphing in this lesson or seeing how this is true. We're just going to learn the rule, and then we're going to be talking a little bit about linear and nonlinear expressions, and we'll come back to it later in 8M4, and you're going to see, you're going to understand this building block. So this is just a building block today. It's kind of a little hand wave, and I don't always like to teach this way, but this is the way the chapter teaches it, and I think it's reasonable. So we're going to talk about how you identify a linear expression, and the rule is not too tricky. The key is any of a linear expression of an expression is linear if it can be simplified to look like m times x plus b. So m is any number, and b is any other number. And that, and this could be positive or positive or negative number. Okay, because numbers can be positive or negative. So, for example, these are all examples of expressions that have this form. So let's look. 2x plus 1, because that's any number times x plus another number. How about this one? 4x. This is where b equals 0. And this one, m equals 2 and b equals 1. Here, b equals 0. So 4x does have this form. Also, similarly, 6, because in this case, m equals 0 and b equals 6. So these are just examples of expressions. You could also have negative 2x minus 4, because the number can be negative. You could just have negative 10. You could have negative 3, 3/2 x, because numbers can be fractions. So these are all examples of linear expressions. Now let me give you another one. So these are some of the more straightforward examples. Now my question for you, is this a linear expression? 2x plus 5x. Is that linear? And the answer is yes, because it can be simplified to, what is this simplified? 7x. And 7x is of the form mx plus b, where b is 0. What's m? M is 7, and b equals 0. So this is 7x plus 0, which is equal to 7x. Okay, question. Is this an expression? 4x minus 10 minus 4x minus 2. And the answer is yes, because it can be simplified to, 4x minus 4x, combining like terms, is 0x, and negative 10 minus 2, that's 0x, and that's minus 12. So that's 0x minus 12, which is equal to minus 12, where m equals 0 and b equals minus 12. All right, hopefully you're getting the hang of this. Let me give you a few more examples, and you can try. Are these, okay, let's give some examples of things that are not linear expressions real quick. And then we'll do some samples. Okay, x squared plus 10. This is not a linear expression. Not. Because I have an exponent in my x term. Not a linear expression. So what else is not linear expression? So x cubed plus x squared plus 2. These are all going to be not linear expressions. Again, because I have an x cubed term. My x term has to be just an x with no exponent, or a hidden exponent really of 1, right? These are all exponent 1. 1 over x is not a linear expression because my x has to be on top. Not. 1 over x squared is also not a linear expression. 5x plus 1 over x squared. This is also not. Even though 5x would be a linear expression by itself, the fact that you have this extra plus 1 over x squared means it is not a linear expression. If you graphed any of these functions, they would not be a straight line. We haven't proved that, but it's true. So let me go and let's create a new window here, and I'm going to give you. Let's just go through and let me give you like 10 examples, and let's see if we can make heads or tails of whether they are. This is a U try, and the question is: are they linear? Can you make them look like some number times x plus b? Nonlinear would be anything that has an exponent that's not, not 1, right? Because mx has an implied exponent of 1. Exponent that's not 1, it would have, a variable on the variable in denominator, but variable in denominator. These would be nonlinear. Okay, so let's look at a bunch, and I'm just going to write these down. Okay, so now pause and try. Okay, I assume you're back now. Let's give out our answers. This is yes. This is yes. This is no. Our problem here is our x squared on the bottom. This is yes. And if I take this same thing that's a yes and I put it on the bottom, it's a no. My x term has to be on the top. This is equal to 0, and so yes, that is. That turns out to be this is m equals 0 and b equals 0. So this does 0 is a constant. All constants are linear expressions. No, because of our x cubed term. This is no. This is yes, where m equals a fourth, and that's a number. It's some number times x, and then our b equals 0. So this is 1/4 x plus 0. And this can be simplified to 203x plus 0, or 203x. So yes, this is a linear expression. Okay, so hopefully you got the hang of this. You know, we came at you kind of quick. We've now understood, or we've gone over what is a linear expression, and we've gone over the difference between expressions and equations. Now we're going to just go straight into the homework help. And so on this homework help, your job is the whole key of this lesson 2 is we're going to use the building block of lesson 1 along with what we learned in lesson 2 and answer some questions. So lesson 1 was all about taking words and converting them into equations or expressions. Lesson 2 is identifying linear expressions. And then, so we're going to put those two together. So we're going to take A, for example, we're going to convert it into an expression. Then we're going to use which is lesson 1. Lesson 2 is to decide whether it's linear or not. So I'm going to leave you to these 4. So I want you to pause and try. And we'll get out our happy cats. Okay, we're going to go in like this fuchsia kind of range here. All right, so I assume you've tried these 4. So let's write a number, well, that's x plus 4. Well, there's our expression. Is it linear? And the answer is yes. Because my m is 1 and my b equals 4. So I can write that as 1x plus 4, which is x plus 4, which is what we have here. So the answer is yes. A number squared. A number squared. That means a number to the second power. X squared, and this is no, because there is an exponent. An exponent that's not 1, right? Our exponent is 2. No. 2 times a number. Well, that's 2 times the number, 2x. That's a yes. Equals 2, and our b equals 0. 2x plus 0. 2 divided by a number. We had 2 times the number but is 2 divided by a number? And the answer is no. Because variable is in the denominator. All right, pause and try. Pause plus try. The sum of the sum of 2 consecutive numbers. Now, I assume that you went back and you remembered how we do this. Consecutive numbers, well, if x is a number, then x plus 1 is the next number. So the sum of 2 consecutive numbers is x plus 1. Well, is that a linear expression? Well, it doesn't look like one, but it can be simplified. Simplified to 2x plus 1. And so the answer is yes, this is a linear expression. M equals 2 and B equals 1. F. If I triple the number of apples and then eat 2, So the number of apples, that's going to be our x. So I'm going to take our x, I'm going to triple it, which means 3 times x, and then I eat 2. Look at that. That is a linear expression. M equals 3 and B equals -2. Yes. Cost to buy tickets for some number of people if the tickets are $7. Well, we can answer this quickly. Some of you probably can do this off the top of your head, but let's just look at this. If I have 1, 2, 3 people, let's see. 1 person is 7, 2 is 14, 3 is 21. So if I have x, it's what? So let's see. How did we get from here to here? The number of people, and the cost. This is times 7. It's times 7. So it's, let me see. Let's do this differently. So to get from here to here, what did I have to do? I had to multiply by 7. 1 times 7 is 7. 2 times 7 is 14. So x times 7 is our cost if we have x number of people. So 7x. The answer is yes. M equals 7, B equals 0. 3.5 times the number, we're back into easier mode, 3.5x, and the answer is yes. 3.5, M equals 3.5, and B equals 0. All right, let's go to the last one. So we have only 2 more. And again, this is the last of the homework help. You know what I didn't do? Just a sec. We're going to go back here because we've been doing some hard work here, and we need some reward for that. Happy cat, happy cat, happy cat, happy cat. Happy cat, happy cat, happy cat, happy cat. And now let's see if we can get our 2 remaining happy cats. A number times a number. Let's see, what's that? If a number is x, times the number is x, times. So x times x, well, that's what? That's x squared. This is no, because there is, say it with me, an exponent that is not a 1. Let's see if we can make sense of this J. Let's happy cat this guy for those of you who got that one. 5 times the number times 10. So 5 times a number is x, times 10. Well, we can use our commutative property of multiplication and say that's 5 times 3 things multiplied. I can reorder them. 5 times 10 times x is 50x. And so yes, if M is 50 and B equals 0. And our last happy cat. Whew, that was a lot. So what did we learn? We learned the difference between linear and nonlinear expressions, what the form has to look like after we simplify an expression. We learned what the difference between an expression and an equation is, which we kind of already knew from, I think that's a 7th grade standard, but we relearned it. There's a lot of recycling, spiraling in Eureka Math, which I really like. We come back to, we learn principles, we come back to them at a more difficult level, and we keep re-energizing and reinvigorating and reminding ourselves with strong vocabulary of when we talk math and we use math vocabulary, it helps our minds remember it better. Believe it or not, that's what the research shows. It also shows a deeper level of understanding. And then finally, we did a lot of work with writing expressions from identifying whether those are linear expressions or not. Good work today. I am very proud of you for sticking with me. If you like these videos, refer them to your friends in class. If they're helping you out, tell your friends about it. And then have them subscribe, and we'll just keep doing more of these videos. As long as you guys keep watching, I'll keep doing them. All right. Take it easy and peace, and enjoy math.